Hello everyone and welcome to Moxa's webinar, Energy Savings Through IP Connectivity. I'm Martin McHugh and I'll be your moderator today. At the end of the presentation, we will do a Q&A session and take as many questions as we have time for. Today's presenter is Paul Wacker. Paul is the Product Marketing Manager for the Industrial Device Connectivity Group here at Moxa. And with that, I'll hand it over to Paul.
Martin, hey, thanks so much. And for those of you joining us today for this webinar, thank you. I know you're all busy, and we have a great session planned today. And I'll be taking you through this. A little broader than some of our topics, and I think quite relevant. So hopefully when we're finished, you'll all learn a few tips about how to apply, some technology to solve some real-world problems on this. With that, let's go ahead and get started. And again, we'll reserve some time at the end of this session for any questions you might have, and finish out at that point. Just a real quick of what we're going to cover today in these next 30 minutes. Just take a little look at some of the things that we're all facing. I know even here at Moxa as a business that some of these things are relevant to what we do. And we wanted to share some of the things we've learned and some of the technologies to help you apply this to what you do through this. I thought this is maybe a good starting point because this is a little bit of a broader topic than we normally do and a little more basic. Let's have you tell us a little bit about what you'd like to get out of today's session, right? So we've got a couple questions up here for you. And I know that different folks here are looking for different things that they're looking to achieve. Are you looking for some tips on energy savings that may help you in your day-to-day activities, or are you looking for really more of how can you automate some of the processes that may be manual with what you're doing? We're also going to try to cover a little bit about IP networking, and a lot of that by example, to give you some ideas of how to apply the technology to solve some real-world problems. Is that more about what you're looking for? Or maybe it's a little bit of the last one, all of the above. So if you give us a couple moments, we'll go ahead and do that and take a look. And great. So I think we should have a good agenda for you then. It looks like we've got, all of the above really applies to a lot of you folks today, and that should be real relevant. Martin, why don't you go ahead and go back to the slideshow if we would. Okay, great. So thanks for that. And a couple of you just joining us now, let's go ahead and kind of take a look at this. So I think the main premise of this, and whether you're looking at how this applies to whatever part of business that you're involved in, right? I think one of the challenges we find are rising energy costs, and I'm going to mix a little bit here of energy as well as a specific segment of that being electricity costs. And I know this is quite variable, depending on where you live. There are different rates for this, and of course based upon the size of your business there are different types of ways that you may have to pay for your energy usage. Overall, I think it's safe to say, in looking at some of the trends that have been taking place, that the cost of energy is not going down significantly. Yeah, I know that if you look in the news and see that the the wholesale price per barrel of oil is down, if you look more longer term trend, the general trend is that they're increasing. So what's that leave you to do? If you take a look at that a little bit distributed as to where those energy usages are by category, this includes all different types of fuels. It's probably not too much of a surprise to you to see that there are a couple segments that this falls into, and this came through, there's some great materials provided by Schneider Electric that has kind of brought a lot of this down to bite-sized chunks to visualize some of this. One of the main parts of this is, over a third, nearly a third being used, for industry, and that's probably more pertinent to a lot of us into what we do. And even with industry, parts of our businesses are more related to manufacturing as well as to other adjacent types of buildings and so forth. So that's a bulk of our focus here. Some of this also goes to residential and transportation usages, and perhaps some of you might be involved in different types of transportation as well. I think this really kind of helps to put things into perspective a little bit. And the other part I think that's really kind of fascinating, and especially in the last 5 years, is data center usage. There's a lot happening, and I saw a real interesting figure. I wish I could remember the exact figure for it, but every time you do a Google search, they've done some analysis to find out how much it costs to do a simple search when you look at the infrastructure to provide connectivity to the servers and the remote data center for that. I thought it was fantastic, and maybe the next time I do this webinar, I can kind of have those figures up here just for a little bit of a fun figure to look at. But categorically, here's some of the areas that you find energy usage, and we're probably going to spend a little more time looking at that industry segment and the infrastructure. Now, if you take one of those segments, and this was one that I thought was interesting, just seeing for just a conventional commercial building, for your operating expenses, right? How does that break down? Some are pretty predictable for what you have. The one that I think is interesting is in that energy usage. So, about a third of that goes into energy. Again, you remember that it's going to be a little different. Of course, you folks, maybe we have a few of you folks here today that are up in the northeast of U.S. and Canada. I know there's been some really tough winter weather for you folks. In that case, you probably got some above average energy usage this year. But a huge part of that, and when you couple this with that aspect of, hey, the energy costs aren't going down, how are you going to be able to be more efficient at what you do? It kind of points in the direction of, hey, is there ways that we can kind of minimize our energy usage and do that? So that kind of is where we're going to go next is, how can we realize some energy efficiency? What are ways that we can do that? Since we can't control the production and distribution costs, and where we're kind of relying upon our utility, unless we're undertaking other initiatives such as doing things like PV solar usage that you can apply at your own facility. By the way of which, I didn't talk about in the seminar, but even here at Moxa, we've put in a really large-scale PV solar installation into our worldwide sales and marketing headquarters here in Los Angeles. And that's one of the ways we've kind of, lowered our carbon footprint at the same time of, being more efficient at what we do. So let's take a look at some of the things that you can do, right? If you look at it categorically, there's about a 20 to 30% savings you can realize. And in order to do that, it takes a couple pieces to put this together. And it's not just one simple solution that you just simply change out all of your lighting to high efficiency lighting. It's really a methodology, and I wanted to present some of this to you as kind of some things to think about and to help you with your strategy. In that first phase, this is the easy one. This is the low-hanging fruit scenario. What can you do to reduce your usage, right? So this is energy efficient devices. This is looking at some of the things that you've installed, and this kind of has two parts to it. Some of this is easy to do, like I mentioned, the example of energy efficient lighting, right? You can go in and get rid of, if you still have any incandescent lights, replace those with high energy, high efficiency lighting, right? You may look at some of the types of things you have in terms of heating and air conditioning and maybe look at doing some capital expenditures to replace those and do that. But that's only part of this, and that's only part of the savings that you're going to get initially, and it takes a couple other steps to do that. The next step on this really takes that to the next level, and this is by optimizing that through some form of automation. So let's say one of your strategies is to look at how you're utilizing your heating and air conditioning usage, whether it's in an office or an industrial facility. So, for example, if you're only running one shift a day in your manufacturing plant, and there are times that the facility is not in use, if you're not already doing this, and probably a lot of you have already taken this step, you can have setback type of settings after the shift is finished to perhaps let some of your energy usage not cool down or heat up to quite to the same level, and take some automation within your process with time of day scheduling or things like that. In other scenarios, and we'll talk a little bit more about this, some of you may be charged by peak demand. Optimization can come through optimization to reduce your energy demand and shave those peak demands. This might mean different types of scenarios where you can not turn on certain pieces of equipment at that peak time and schedule those a little bit, or to be able to balance your usage to not hit those peak demand charges and have to pay higher rates for your electricity usage, right? So that's through the automation end of it. The other part that a lot of folks, maybe don't spend enough time planning for and actually making sure that they have enough resources to do this is that monitoring and maintenance. So yeah, it's great that you do these things, whether they're capital expenditures or, improvements for automation, but there needs to be time set aside for monitoring and maintenance, right? And this means that you've got to look and make sure that things are adjusted properly. So you might find that after you've installed it, that you might need to come back and fine-tune some of these things. Or you might need to come back and do some minor maintenance to keep achieving those cost savings that you've done, throughout the process. And this is important. And the more important part is that folks often forget is that when you do this, that if you don't stay with this program, that you can lose a significant amount of your savings by not doing that. So again, you have to stay with this program. And if you're, especially those of you folks that haven't implemented these programs, it's real important for your team and your management and the others within your organization to understand that there is some expenditure needed to keep this as an ongoing process. And the more you do this and close the loop on the feedback, the better that you get with this. So again, upfront sometimes for capital expenditures, let's install the automation. And then make sure not to forget a real important part of this is that monitoring and maintenance and being able to, keep that efficiency that you've done up front throughout the whole life cycle of this program. So what you find are kind of 4 key areas, and I think this, and I'm kind of an industrial automation guy, I always think of things as closed loops, like a PID loop, right? You need to be able to have that feedback in order to be able to know how effective are we doing, how effective of a job are we doing, and how can we make sure that we can kind of achieve that desired result, right? What are our KPIs, what we're trying to shoot for here? So it's really 4 things, right? We want to find out where we can get savings. We want to do the action to achieve that, fix the basics. We want to be able to monitor it, with what we implemented, are we getting the results we expected, and keep monitoring and improving that in a closed loop. Now, there's another way to kind of visualize this if we break this up a little bit. And let's go into a little more detail about how you can do that. So it's real easy to do the first stage, and this is something you can also ask for help on. You may have existing relationships with your utility. A lot of them offer services, or perhaps with some of your vendors that are helping out with some facilities management. A lot of them have services to come out and help with some of this. Finding out, where are we using energy? Some of this may not be so easy, and sometimes it's been a very, very manual process. In part of this auditing process, you might even think about putting in some extra instrumentation to see where this energy is being used. And that's going to be some of the discussions we have here today. Then you're going to fix the basics, right? And in doing that, it's, maybe in some cases doing some things for additional insulation, right? It might be doing some things for energy efficient lighting. It might be some capital expenditures for some different types of equipment to maybe replace something that's 20 years old with a better technology to do that, and so forth. Then the next step is applying that automation and regulation. This means maybe doing something a little different in how you go about this. I'm going to spend a little time talking about some technologies that some of you may be familiar with to get some huge savings in electricity usage through variable speed drives, for example. And then carrying on through that, the next step of this is really that monitoring process. And if you notice, we've kind of drawn the closed loop here. Once you've done these, then you got to come back around and take another pass at it, and do that on a continual basis to keep ensuring that you're going to get the savings that you're looking for. Okay, pretty basic. Well, let's delve a little bit into some of the tools and technology, and here's where we're going to see a little bit of the Internet Protocol monitoring coming in. And I'm going to save a little bit more discussion for Internet Protocol for the latter half of our discussion today, and I really don't want that to cloud some of the basic techniques. And when we talk about Internet Protocol, just at this point, kind of figure that as being just a technology to move information from one point to another. And just to give you a little preview of that, that can be from your office down to the shop floor. It can be from one facility to a remote facility. It can be around the world, and I think that's one of the exciting parts of Internet Protocol monitoring. There's so many ways to deploy it, and if you use that technology, it gives you just a huge amount of flexibility. So one of the things I find quite often is that you get the common thing of, gosh, I've got something I'd really like to see more about my energy usage, but I don't have an easy way to capture that. And how can we have more visibility to what's happening? I'm going to be a little bit high level in our presentation today, just to kind of give you some ideas on what you can do and not drill down to all the ways you can do it. But certainly, if you'd like to have more discussions, we can help, put you in the right contact with the right folks to do some of this. And oftentimes you'll find this is a multi-vendor solution to do some of these things, but at least you'll have some ideas on some of the things that are realizable today with a very minimal investment to do them. In the case of, how do I find out where I'm utilizing energy? One of the easy things you can do is deploy remote I/O modules to be able to see what's happening in different facilities and different locations of your plant, right? And that can be done a couple different ways. If you know of different types of things to see when is my lighting on at this time of day, when does it go off? Or, do I have things such as power usage that I can monitor from things such as, for example, an analog signal. When I say analog signal, something being maybe a 0 to 10 volt signal, or 4 to 20 milliamp signal coming from some process instrumentation, or maybe something as simple as a thermocouple for sensing temperature or an RTD. It's really easy to put a small little module in place nearby where that is and utilize that remote I/O module to bring that across your network. And the other great thing about IP connectivity is a lot of you folks already have it in place, and it's just a matter of coordinating with your IT team of giving you access to that and being able to bring that back to some central monitoring location. So, there's these things called remote I/O modules that are able to be installed at different facilities to be able to bring that back and monitor it. So that's certainly one thing to think about that helps give you, some eyes and ears and ways to sense what's happening. How about another way to do this? Now, perhaps you might have some systems installed, but maybe your system can't quite get far enough out to that attached device. Some of the examples I see are particularly in manufacturing environments where maybe there's a control room or maybe there's some part of facilities management that has some of the tools to do it, but they don't have the way to get access to it. And maybe you want to pick up some thermocouple values to sense temperature remotely, but you don't have a way to get a remote. And maybe you're looking at things of doing this over Wi-Fi, or maybe this is going to go over a cellular connection, or maybe this might even be over a twisted pair copper with technologies to utilize existing phone cabling you have in place. So again, you can do things like taking these remote I/O modules and utilizing these kind of in a back-to-back, and we call it a peer-to-peer technology, where you can basically have, and let me turn on my pointer here so I can kind of help illustrate this a little bit, where maybe this is the thermocouple over here on the right-hand side that you want to sense remotely. You basically want to bring this thermocouple up and maybe bring this across your network over here to a 0 to 10 volts analog signal to be able to monitor from maybe a management system that you already have for facilities management. Great technology here to be able to use these types of technologies in, say, a peer-to-peer type of environment to do that. And that's totally realizable. And we're talking about a real inexpensive I/O module that you can be able to have these guys point to one another to mirror that signal across your IP network and do some really simple things. And we're talking about something you could set up in a matter of a couple hours once you know kind of the infrastructure you want to use for that. So really interesting technology. Again, these can be on-off signals of a contact closure, a signal of 24 volts or 12 volt signals. They could be time varying signals that we call analog signals. Time varying being maybe 0 to 30 volts DC. Could be 0 to 10 volts DC, 4 to 20 milliamp loops, thermocouples, RTDs, temperature sensors, and the like. Now, sometimes the infrastructure of getting it's not quite as important as having some intelligence to that remote location to do it. We often find this with some of our customers and clients and our partners that are working on remote applications, maybe that don't have quite a good infrastructure. And maybe an example of that might be a remote facility that we want to be able to capture that and maybe transport that via cellular signal. And maybe we don't want to have a consistent, full-time connection, but we want to be able to push that over the network, say, once a day. This is a great application for a device called a data logger, and data logger takes that same capabilities of the remote I/O device, but has ability to do a little bit of application programming inside that can be as simple as filling in the blanks for a couple of parameters like, hey, here's what I'd like to collect, here's how often I'd like to collect it, and here's what I want to do with it. And then, say once a day or once a week, we want to push this over to a central location to capture that. This is really important for that first part of your phase of doing the auditing, because this can give you some ability to see, hey, how much am I using at this location? And how does this fit into the overall scope of things that are relevant to what I do? So this is one of the things to think about is data logging can be a real efficient tool to have to help you be able to quantify where you're utilizing energy throughout your operation and throughout your business, to be able to help you kind of formalize the right type of strategy to put into play the things that are going to help you realize the efficiency that you're looking for. Now, let's move on a little bit, and I want to talk about another type of device. We've talked about pretty basic things, that we can just tie into existing infrastructure without having to do huge capital investments, which I know are difficult to have to get the justification and to show, why we want to do those capital investments. And this one ties in a little tighter to these devices, and we're talking about tying into maybe more intelligent devices. When I talk about intelligent device, we're talking about things that may have two-way information exchange. And categorically, the types of things we see a lot of, particularly in this segment, are connecting into things like power meters. And a lot of times the facility management teams have these installed. And we even find that a lot of times these are installed only for local usage, and they're not tied into a larger system for facilities management or for your purposes in terms of trying to do energy conservation. And I use the example here, and it's a really good one, of a three-phase power meter. So you might find this, in your plant, on the plant floor, even within your facility, in the facilities control room, that you'll find these installed in panels. And they might be tied into some of your equipment locally, but they're not being utilized for this optimization or for the auditing process. And if you work with your teams internally for facilities management, plant management, you can have access to these. You will need to have a way to bring these across your network. And categorically, there are devices that we call a gateway. Sometimes folks will call them a protocol converter, and a few different devices. And their ability is to talk to these devices like a power meter and make these available over your IP network. The neat thing is that these are very transparent. It's easy to get these accessed remotely. There's a lot of free and low-cost tools to let you be able to kind of bring this information into a central location to do monitoring. And these are really easy to do, again, at that very early phase of your project where you're looking at, where am I using power? How does it fit into the overall scheme? How does this help me kind of understand where there's some low-hanging fruit for me to kind of invest in for the first few phases of this project to show those quick energy savings of doing some things right? So again, you can't be successful in any of these projects unless you can know, where you can get the most or the best usage of your return on investment, right? Now, I thought it might be good to give you folks kind of an example of that, and this is one that it's been interesting to see over the last couple of years, the increase in investments of this. And it's really interesting, and one of the applications that we see a lot is within the data center, But even though I say data center here, you don't have to be the IT infrastructure management team to do this. You can do all the same things for facilities management. The concept is that you've got power coming into your facility. I think it maybe gets a little more attention for the IT infrastructure management because it's a critical part of the business, right? That you have to make sure you have quality power coming in. You have to make sure that you have high availability in the power. You need to make sure that you have backup power in case there is a problem with the utility or due to weather. I noticed that for those of you folks in the Northeast that we saw some things with some of the utilities, worried about having interruptions to the infrastructure, shutting down some of the nuclear power plants, meaning that there could be periodic, a short stop in your energy being provided during switching and those types of things. But I think you can see the value in even other parts of your business for this. And this is where you can take that power meter, drop in one of these units to be able to tie this into, your control center. And this one happens to use something we call a Modbus gateway, but there are other protocols available. I don't want to be, limit this only to Modbus. This just happens to be, a de facto standard that's been out there for a long time. Almost all of the vendors of, power monitoring equipment, have this as support. There are others available, but again, tie into that power meter, bring that across your IP network, and bring that back to one or more locations. And that's one of the things that's not apparent in there. You can have multiple different parts of your organization utilizing this data, and there's ways to segment that and protect that based upon what you're doing to make it really easy to use and efficient for that. So good example here that I think kind of brings it home to here's a real-life application of how that can be used, and this is looking at how many watts am I using in this location? If you want to drill down further, there's a lot of information available in these meters that are kind of interesting. So with that, let's take a quick break. I know I've done a lot of talking here. Let's give me a chance to give you guys a chance to see, what's kind of your priorities at this point here as to how you might apply some of this. Are you looking really in terms of what you're seeing today as a means to do, just monitor some of the things that you already have existing? I think certainly we gave you a couple ideas on how you can very easily and quickly be able to monitor some of the things that are already installed. Or are your needs a little bit more of maybe looking at how can I do more remote control? No, I know we haven't talked about that. That's kind of coming up next. But is that more important to you? Or is it maybe a little bit more of automation or integration of different devices, equipment? And Martin, why don't we go ahead and close out the poll and take a look at that. So we see, again, kind of similar to result to where we started. Again, it goes to show, as we expect to be pretty diverse group today, we've got a pretty good mix of that, which is good, which I think we've done a good job of kind of capturing some of the things that are relevant to you here today. And with that, I'm going to go ahead and switch back over to our slides. Thanks for your help with that, Martin. I'm glad to have some good help today, and we'll kind of move on to pick up with the rest of the session. So let's talk a little bit about some of that interest that you folks have for that automation and regulation. And this is a really encompassing topic that covers a lot of different types of things. And again, that IP infrastructure tends to be kind of that horizontal platform that supports that. Let's take a little look at that. And I'm going to stay a little high level, and by no means, we've got such a short amount of time today, we can't cover everything, but I'd like to take a look at some of the real simple things. And there's a lot of great solutions out there from a number of vendors that do some simple things like time-of-day scheduling. And this is even available in something similar to these small remote I/O modules we talked about, that if you have, for example, a part of your facility that you want to be able to do a little bit of scheduling. So, hey, I've got some equipment in this shop, and I'm not using it after hours, and I'd like to turn this equipment off. It's as simple as tying a piece of a little controller into this and setting up a schedule. And the schedule might be, hey, Monday through Friday after 6 p.m. in the afternoon, we turn this equipment off. And it's real simple to do that type of thing. And even if you're not a programmer, these types of tools have real simple setup software with which to do that. And even some things like that can make a huge difference than what you have today. So don't forget that. Sometimes the most basic things can have a big impact with what you do. And this will vary, of course, on what types of equipment that you have. Again, it could be lighting that you're looking to do this with that are non-essential. It may be some supervisory systems that you might have. We find in some cases there are some shops that have like CNC equipment within their shop floor that you're using. It may be some supervisory functions. The other thing you can do with this is it doesn't have to all go off at once. If you install this type of solution, you can kind of schedule how that's done to shut down things in a certain order. And the other advantage is, I've seen this, not only in factory environments, but also in IT data center. Sometimes things have to come up in a certain order. You can also make sure that they come up in the same order, reverse of how they shut down with this type of investment for doing a controller local to do that. Okay, and this is typically with digital type devices for on-off. But remember that you can also do analog devices if you have things that have to come up in a ramped type of fashion. Another one that's kind of interesting and really one that's not real well known, and something that if you'd like to have more discussions, I would suggest that you talk to your representative from your utility company. And this ties into demand response. And I think I can probably relate to this being here in Southern California more than a lot of you folks. That here in Southern California we have some real challenges in the summer. We've had some pretty hot summers, especially last summer on looking back to some of our usage. That you've got hot weather, everybody turns on the air conditioning maybe a little higher than normal, and it's really a challenge for the utility that for typically a handful of days, maybe 5 days a year, that they have to turn on everything they have to have enough demand to heat that peak usage. The concept is for those customers that have some flexibility in their usage, being able to shed some of that load on demand, and the benefit for those customers is incentives. And those incentives have come in a lot of ways, maybe in a cash incentive, they may come in other types of incentives, and this really varies from utility to utility. And this has started to be driven towards something called demand response, and there's even a version of this called automated demand response, or ADR. There's even an open standard behind this that's being driven that you can automate this, and where you can get to the level, and this takes a lot of planning, of course, for you to do this, but you can have some significant savings on this, where the utility will send out an alert, hey, we know we're going to have a high demand day. We may need you to participate in the program. They'll give you notice of advance. And then once that happens, they're going to send a signal to you, and you'll need to install some equipment and send that equipment down to your facilities to be able to do that. Of course, it's not going to be critical systems. These are, systems that may not be so critical. So it may be that, hey, it's okay for us maybe to kind of set our set point up for air conditioning in the shop a couple days a year in Southern California for that. And it's a very tailored thing that takes a little bit of coordination. But an interesting thing, and even for maybe 5 days a year, there can be some significant payback for this with what you do. So something to think about, and this kind of goes into play of having ways to communicate. Some of this will be into your facilities management. The real challenge is, how can I get my facilities management system to talk to the different things within my business? And some of these may be within one building, they may be multiple buildings. And this is where you really want to think about, how can I leverage my existing IP infrastructure? How can I put other things in place to do that? And can, again, be some very interesting things that you can apply to have some great savings. Now, I'm going to spend a little more time on this next one, and I think a lot of you are familiar with this, but maybe not to the level of some of the things achievable. And this one can have both some short and long-term benefits for you. And what we're going to talk about is different types of loads in your facility that are driven by things specifically with pumps and compressors. And we're going to get a little technical here, and some of you may be technical and you'll probably eat this up. For those of you who don't, that bear with us, and we can certainly put you into some other references to look at some of the different technologies you can implement. And it looks at things that are things like pumps and compressors, and maybe even some of your factory automation equipment. I think the best example that all of us can relate to, and I was really kind of looking at something that everybody could see, is your heating, ventilation, air conditioning systems. A lot of these systems are meant to be on or off and nothing in between. So the ways that they've kind of regulated airflows and temperatures and the like have been by running the system at full blast and opening and closing dampers, or running the systems on and off and cycling them, which doesn't give you good temperature regulation. And it really, a lot of people are still doing this, and there's some great ways to improve this. And I want to talk about a couple of those because they're not really obvious, and some of the payback can be huge, and it can be very quick, if you decide these are the types of things that you can apply to with what you do. So the types of loads we're looking at, and I used HVAC as an example because you have, fans that need to be driven by a AC motor. You have pumps that may be pumping different parts of things for chillers within your facility, and some of the handling of that for evaporative coolers and the like. There may be other parts of your facility that are using this for different types of things, and this all relies upon general purpose AC induction motors, which everybody has, independent of what you do, whether you're a manufacturing plant or even an office building. And when you look within industrial manufacturing, about 60% on average, you can vary a little bit based on what you do comes from that. And a lot of these are meant to run at a fixed speed operation only, run or stop. And then, maybe some form of cycling on that, right? And that's great until you look at how much of that, until you look at what you can do to, get some benefits out of that. Now, one of the things that we're talking about here is that control, right? So it's what you mentioned, on-off. It's open and close a damper to change, how much hot air you get blended with the cool air. And it may be open and closing valves, full open, full close to blend that, right? And that's kind of the old way to do it. Well, one of the things that is really interesting here is what you can do, and there's something, and I'm not going to get real technical here, but I'm an old industrial automation guy, and I learned about some of this many years ago, and it's kind of amazing. There's something called the Affinity Law, which basically said that if I can reduce the speed on these pump and fan loads just a little bit, the amount of power is huge, because the power required to drive these loads is the cubed power of the speeds. So you've got that, hockey stick effect on this, right? So the takeaway on this for you is that if you can run, your process, it's a 70% instead of 100%, and you can reduce that speed or flow just a little bit, that you can use 40% of the power. And that's huge. I mean, that is just a huge impact that it has. And a lot of people don't understand this little basic, basic thing that you can do. Now, that's the simple part. How do you achieve that? And the way to achieve that is with a little bit of technology. I imagine a lot of you folks may have this in parts of your organization. For those of you that don't, it's really something that you want to talk to other people within your organization to put this into play, and it's something called a variable speed drive. Some people may refer to them as inverters or VFDs or a couple other terms, and the basic concept is we insert this in line between the AC power source and the AC motor, and it's able to vary the frequency going into the motor, which in turn gives us variable speed at the shaft of the motor. And that's the magic that goes into it. And the technology here is amazing, and the cost point of this technology is also just amazing. So yeah, it's going to be a little bit of a capital expenditure. Yeah, you're going to have to spend a little bit of work, working with the facilities team to either, do this in-house or bring in the right team to do that. But when you look at, being able to, take that energy usage and cut it down to, about almost a third of what it was before is just incredible. With what you can do. And again, this is not rocket science. It's some pretty basic stuff that when you reach out to those, whether within your team or within your organization, you can have some huge savings. And where I want to go with this is that this is only the first step. There's a little bit more to this when you go past the first phase of being able to install this efficiency. There's that adjustment part of this that I want to kind of talk about as well. But before I do that, I want to kind of show maybe kind of a sample application of that that you might want to employ. And here's an example application of, maybe having an industrial facility where we've got air handling in that manufacturing environment that maybe in the past just ran, full blast, and wanting to tie this into some of the systems in place. And this system in place actually had to use a programmable logic controller as the customer's preference for the energy management system. And some of you folks may have expertise to do this and do some of this in-house, while others of you may utilize a contractor or systems integrator. Often you may find that there are different technologies to get together. And this is showing where there's a preference on the control platform, there was a preference on some of the technology to use variable frequency drives. And one of the things that a lot of us find today is utilizing a best-of-breed approach, so I can pick the best solutions and integrate those. And this is where IP technology comes to the rescue and giving you the ability to be able to converge this stuff onto a single network and utilize a couple tools. In this case, we're utilizing a gateway that's able to talk Modbus, which almost all of the VFDs that are on the market right now, even the smallest, most inexpensive ones, have a Modbus serial interface. And if you utilize a gateway, you can get that onto Ethernet. And in this case, even convert between vendor protocols, going from Modbus serial on the drive to Ethernet IP on Ethernet. And just be aware here that when I say Ethernet IP, this is a technology from Rockwell Automation. Some of you folks may know as Alan Bradley, being able to get that onto the network and make that part of your control strategy. So again, lots of tools and technologies here when you know how to integrate these together to achieve what you're looking for. With that, let's take a little look here, and I wanted to kind of keep us on time for that and just kind of delve a little bit into the IP networking aspects of it, right? So this is the part I really wanted to save to last, and if you don't know enough about this after today's session, I'd really invite you to come back and attend one of our other webinars. Some of these we have recorded online. We'd be happy to point you to, or engage us at any level you'd like to help you learn more about it. Like you, maybe I kind of came into IP networking late in my career, and I'd always been interested in communications, and I've always been an avid learner. I'm learning new things every day. There's some great things to leverage from this, and we'll talk a little about that. But none of this is possible without having a way to transport that sensors and actuators that are there and being able to use a lot of infrastructure that you have. A lot of you may be amazed at how much infrastructure you have today existing with wired copper cabling that you can take advantage of. And IP has become so prevalent. Even if you don't have it, it is so easy to install a few small pieces of equipment to do this in many different ways. It's just amazing. So let's kind of talk about this a little bit and how to do that. And although I'm going to stay high level, I want you to realize that this is just not difficult to do. You probably have a lot of people that are at your fingertips that can help you do this. So the key thing is, how do you have those eyes and ears to get back out at that stuff, right? So how can I monitor and manage that remotely? The other thing I wanted to impress upon you folks is that when I say IP, IP is not bound to a specific media type. So a lot of people think of Ethernet, think of IP networking, and kind of think of them as the same. And yeah, that's possible. And yeah, within your office, you probably do a lot with that. Be aware that IP can go over a lot of different technologies. IP can go over Cat5 cabling. There are technologies such as DSL extenders that we can take and run a Ethernet connection on IP over a single twisted pair of copper that you might have going to a remote building in your manufacturing plant. Of course, Cat5 for Ethernet, right? We can take IP and we can run over that over fiber optic cable. Fiber optic is great when you've got to go a little further. You may have some of this already installed, and you may be able to even do things like direct bury this cable in a trench if you want to go a little further. Some of this may even be wireless, and wireless technologies can range to a lot of things. It's real easy to set up a little short Wi-Fi link. It's easy to set up a little longer distance link for point-to-point connections. There's even some technologies out there, and it's a little beyond the scope of today's session, that those technologies could even be mesh networks with technologies such as Zigbee, which don't require infrastructure and utilize each device as a way to repeat the signal, and they give you a very rugged and resilient type of network that each device that's installed is also able to carry network traffic for that. Again, the whole concept here is utilize IP as your method of transport, and then these are different tools you can engage to carry that traffic across that. The other thing that I think is so important, and I think we touched upon it a little bit today, is that this is a mature technology, and one of the reasons it becomes so mature and it's become so exciting is it's based on open standards. So you've got Ethernet at the actual device that you can attach to. And some of you folks may even have more mature technologies before Ethernet. Maybe you might have some things like RS-232, 422, serial connections. There are even solutions that we can use with a device we call a device server that can take those assets and get those onto Ethernet that can work as well based upon open standards. And that open standards is really important because open standards means that you have cross-vendor compatibility. Open standards means that what you install now is going to be supported in the future. Open standards means that if you have a desire and have the capabilities in-house to do some of your own development, maybe for some of your custom applications through your IT team, that you can leverage these for things like monitoring and management, or even for application development. It just means you're not going to be roped into only having support from a single vendor, and you can capitalize on that best-in-class type of solutions in the different aspects of your energy management efforts on this. The other thing that this means for IP networks is multiple protocols over the same network. Maybe some of you have some experience working with technologies like Modbus. And if you've got Modbus tied into that power monitor, all you can do is power monitor over that cabling to that. IP technology means that over that same connection you can carry multiple signals. So maybe today you're doing energy management, and tomorrow maybe you might want to do something like remote surveillance inside that part of your facility with an IP camera. So, you know, this gives you future-proof technologies to bring other things across that same network, right? And lastly, and I kind of got ahead of myself here, if some of those assets are serial-based legacy assets, power monitoring, or maybe some instrumentation, or maybe a PLC, that even those old technologies can be tied in with things like gateways or device servers to integrate that legacy serial equipment over Ethernet and IP networks with that. And you know, the whole core of this is how much can you utilize what you already have in place to be able to build upon that, right? So lots to think about in this session, and I think it's been kind of neat to be able to talk about all of this. And I wanted to kind of finish up here before we open up for a few questions on, kind of looking at some of this. And this again kind of came through some things through the U.S. government and a couple industry sources, kind of showing that, in the last several years, that the payback that you can do, and this looked at kind of a large commercial building that had some investment up front to do this. And the time to return on investment has become so short that we're looking at investments that you can get back in less than a few years today. Now, certainly it's tough to generalize this. Each of you probably have different objectives for what you want to do. But if you really take some of the things you've learned today from today's session and apply those, especially up on that front end of doing that audit, and are smart about how you apply that, and smart about the resources that you engage, all of you can realize some significant investments in the short term of months to years to just a couple of years on this, and really be able to show some things to help your organization be more efficient at your energy usage. And the great thing is you can really feel good about this at the end of the day. You can help your organization be more competitive. You can help reduce your company's carbon footprint and feel good about it. And maybe even some of you folks can do things. I know here at Moxa, at our corporate headquarters, have a really neat PV solar system. If you came to our lobby, you can see a nice monitor in our lobby of how we're saving, energy and lowering our carbon footprint. That can be some of the good feeling you can have to show to, your employees and even to maybe your customers to what you're doing to improve life, for yourself and for your kids and future generations. With that, let me open this up for a couple questions, and I'm going to ask Martin for a little help here with this. Martin, I think we might have a few folks. I saw a couple questions come in. Hopefully we can take a couple of those questions. And I know we're a little limited for time, but let's see what we can squeeze in.
Great. Thank you very, very much, Paul. A lot of fantastic information. So now we're going to open it up for some questions. I do have a few queued up here. The first one here is from John. John asks, I've got some power meters that use DNP3 on RS-232. He wants to know, how can I connect these to Ethernet? So I'll hand it over to you, Paul.
Okay, a technical question. Well, good. I think I can handle that one. And again, I think one of the things you'll find here is there's just so many different technologies here. There's a lot of integration. The neat thing is there's a lot of off-the-shelf technologies to do this. And I think it was John. I think for that one specifically, you're in luck because DNP3 is something that's very common in power and specifically with facilities and utilities. That's pretty easy to work with. We've got quite a bit of experience working with that, and that's a simple serial protocol that was typically meant for point-to-point connections. There are technologies that we call device servers that are able to take that serial information and put that onto an IP network and transport that across the network to another location and bring that back out to a serial connection. And that's called technology we call serial tunneling. You can do that with two boxes, basically using that as an RS-232 extension cord. There's also another part of that should one of those endpoints be a server or a computer or some types of instrumentation that's PC-based, there is technology you can leverage an Ethernet port to bring that back to a virtual COM port for that. So yes, it's possible to take advantage of IP communications for DNP3. And if you have more interest, let us know. I think we've got a good tech note on that for more information if you have interest. Let Martin know. He'll be doing a survey after the webinar.
Absolutely. Thank you very much, Paul. The next one I have from Maria, and her question is, she wants to know what types of devices can she connect via remote I/O. So I'm going to provide a little insight on what that looks like.
Great, thanks, Martin. And I tried to show examples where I can, but that's a great question. And I think you'll find a lot of different types of things. From an off-the-shelf perspective, we see things kind of fall into a couple different categories. I think there's two types we talked about discrete signals and with analog. Generally, we find that most of the sensing applications fall into that low voltage DC signals. Those can be on the discrete side of on-off types of signals, typically in that 0 to 30 volt range. If you do have ones that are higher voltage signals, let's say you have something that's higher voltage, we can suggest utilizing other devices to drop down a higher voltage AC signal with a device to sense that at a low voltage DC for a remote I/O block, and for example. In terms of outputs, we generally find those fall into a couple categories as well, of that same range of typically 0 to 30 volts DC, and then relays being kind of that agnostic interface that you can switch a DC signal or even AC signals of say 115 volts or 220, 230 off that relay. But bear in mind when you utilize a mechanical device like a relay that's going to have a certain life cycle of opening and closing, so you want to pay a little attention to that. Of course, in analog, and I think I gave a few examples of this, there are millivolt level scales for analog being a time varying signal, 0 to 10 volts or plus or minus 10 volts being very commonly supported, and 4 to 20 milliamps being prevalent for transmitters for pressure, temperature, and the like. And even if you have discrete sensors like temperature transmitters, you'll find a lot of those being thermocouples and RTDs. So hopefully that answers your question. That covers a lot. There are probably a couple that I didn't mention, but there's not a direct solution for that. You can generally, and sometimes we'll refer customers to third parties for maybe a converter that can adapt those odd signals that you're likely to encounter.
We have one more question, so we're going to try to take this to the last question. I thank you all for so much for your attentiveness and your participation. The last question I have is from Luke. He wants to know what options does he have for wireless monitoring?
In terms of options, this is one that there's a couple trade-offs. I think the big trade-off to think about at the get-go is do you want to utilize an existing infrastructure from a commercial provider like cellular? Those are great because they're easy to install and leverage, a commercial infrastructure for that. The caveat is the monthly payments for that connectivity versus spending a little more money up front with a little planning to install some of that where you're paying the costs through that capital investment for that. That can be very small in case of a wireless access point and a client bridge. And those options are generally going to be Wi-Fi technology, which Wi-Fi, you can do a lot of things with. And there's another related technology that's kind of relatively new in the 900 megahertz band that you can get much longer distances, thousands of feet to miles that you might consider. And then the last one, just kind of categorically because we're limited a little bit for time here, is with Zigbee technology, where you can do low power mesh networking, and that allows you to basically not have to install infrastructure, and the devices themselves in essence become the infrastructure. So this can be nice when you have obstacles like walls that you can get around with, devices on the edge of the wall and the like. So I think that kind of is enough we can take for today, Martin. And let you wrap it up.
Great, thank you very much, Paul, and thank you to everyone for your interest and participation.